computer. That's it. So, well, I'm happy to begin. Excuse me, just a second. No, that's okay. So I'm happy to begin this second online talk. So, second online talk of the C2 IAU C2 Commission. And this time the talk will be given by Dr. Ali Aledari, who is from Iraq. And he's going to speak about, the title is Astronomy in Iraq, the Ancient Wisdom and Modern Wonder. Modern Wonder, sorry. So this is quite a complete story, I guess, coming from Mesopotamia up to now, and including also the founder of that, of course, the importance of women in all that. And so I will let Ali speak, but first I would recall that Ali is an astronomer, a professional astronomer who got his PhD in France, in Grenoble University, and also a postdoc in France. And he's now a faculty member of the Department of Physics at the College of Science, Al-Muthanna. How do you pronounce that? Al-Muthanna?
Yeah, you're correct. You pronounced very good.
Wonderful. Al-Muthanna University in Iraq. And of course, he has published many papers in astronomy, in astronomical journals, but he's also very involved in communication of astronomy, and he's also involved in IAU, in educational part of IAU. He's a NIC, which is a National Astronomical Education Coordinator, and also NOC for outreach. So I think he's very well to give such a talk, and I think it's very interesting for Commission C2, which is a commission communicating astronomy with the public, to have information and to get knowledge about what is done in several different countries in the world. I hope we will have other speakers in the future speaking about their own country. And so now I will let Ali begin. So Ali, please, that's your part now.
Okay, hello everyone. First, I want to thank Sylvie and my colleague in the C2 Commission for giving me this opportunity to speak about astronomy in Iraq. So let's start. As you may know, Iraq has a long and rich history in astronomy, starting from skywatcher and from the ancient civilization in the Mesopotamia, all along the way to the modern satellite. It was home of the first star catalog and early space math. This talk will take you through a key moment in that journey, showing how Iraq helped shape our view to the universe. I have to say that also all information in this presentation is from academic source reference. It's written in each slide when it's needed. Before we dive in and before anyone gets sleepy, here is a very quick video to wake up your curiosity.
We can read, but we don't hear anything. Is it supposed to have some speaking part?
Yes, there is audio with the video. I don't know if you hear it or not.
We could not hear the audio. We could see the video, but could not hear the audio. But
Okay, that's good.
we could read, so it's fine.
Oh,
Ali,
it's fine.
you probably did the screen sharing without that. There's a check mark to add with the screen sharing that you also have to share computer audio. Otherwise, computer audio will not be played here.
Ah,
Oh, okay. Okay. Thank you for letting me
thank
that.
you, Marike. I can recognize your voice.
Okay.
But, well, anyway, is there any other video like that?
No, no, no. Only
So let's go on.
okay. This presentation I divided in five period. Started with the Mesopotamia period, Islamic Golden Age, colonial, and modern era, starting with finishing with the present day astronomy in Iraq. And each period we will focus in four lenses, which is key theoretical advancement and observations, tools and technology used for celestial observation, role of men, this is very important, female contribution and astronomy development, finally with culture, political and social influence. Just to sure you are everyone here and listening, let's start with this simple question. If you can just answer it in the chat box. Who invented the base 60 system and is still used for time and angles just until now? Egyptian, Sumerian, or Babylonians? We have three options and you can put your answer if you want in the chat box. Okay. We have, I think we have a good right answer. Thank you for your answering. So let's start with the first period, Mesopotamia era, from 4000 to 500 BCE. In the land between the Tigris and Euphrates River, ancient Mesopotamia were the first to study the sky in academic and scientific way. From Sumer to Babylonian and Ashurian, they built idea. They shape astronomy for thousands of years. They carefully record how stars and planets move over time. They created the base 60 system still used today for time and angles. They note how eclipse and season are repeated and learn how to protect them. Discovery in this period, the Sumerian made the first organized lunar calendar by following the moon phases. It helped them to plan farming and religion events. Later, Babylonian astronomer added extra month when needed. They keep the calendar in line with the seasons. Finally, the system became the base for many calendars still used today, like Islamic and Hebrew ones. The first map in sky, Babylonian 3 celestial zone, which is Enlil Bath, named after the god of air, contain northern constellation visible year-round. Anus Path in the center, named after the sky god, approximated the celestial equator and contained the sky zodiacal constellation. Eos Path in the south, named after the water god, contains southern constellation with seasonal visibility. Around 1000 to 686 BCE, Babylonians record the star in the clay tablet known Mul-Ibn tablet. They listed over 66 stars and constellation track with their rising and setting, and explain how to keep their lunar calendar accurate using extra month. These tablets are the oldest known star catalog in the world. This system became model for later civilization. It shaped the way Greek, Roman, and Islamic astronomers map the sky. Many of the same star pattern and names are still used today. The most important advanced astronomical prediction in ancient Mesopotamia. We have two, I take two examples. The Saros cycle. Babylonian astronomer discovered that eclipses follow a repeating pattern. now call it Saros cycle, lasting about 18 years, 11 days, and 8 hours. They realized eclipse happened when the moon crossed certain point in its orbit. By around 700 BCE, they could accurately predict both solar and lunar eclipse. Venus tablet of Aminu Sadok, dating in the 17th century BCE. This tablet tracked Venus' appearance over 21 years. It records when Venus first appeared as a morning star and last as evening star. These detailed records show how Babylonians understood Venus' cycle, which repeat every 584 days. For the tools in the Mesopotamia, they do very good one. Key tools that enable a systemical celestial observation. I take, for example, which is water clock, used following water in measuring time, helped Babylonian astronomer keep track of time in night. This made it easier to follow the movement of star and planets accurately. Horizon-based observatoire. Babylonian astronomer use high platform on the top of Zakura building, to watch the sky clearly. The place they placed marked to follow the sun, moon, and the star during the seasons. Many of these buildings were designed to line up with the important sky event. Also, we have shadow sticks. The Babylonian used upright stick that cast shadow to tell the sun positions. They helped mark the longest and shortest day of the year, and when the day and night were equal. These simple tools were the early version of sundials. Finally, you have a clay tablet. The Babylonians wrote their sky observation on a clay tablet. They record star positions, moon phases, and eclipse prediction. These tablets also keep detailed sky chart and early astronomer notes. Now we go to the one of goal of this presentation is the role of women. In Asia Mesopotamia, women especially play a key role in temple-based astronomy. Gods like Anana, linked to the Venus, reflect the deep connection between women and the sky. In Haduna, daughter of the king Sargon, wrote hymn with astronomical reference. Nadito, priestess, track lunar cycle, maintained a star record, and shaped religious calendar. Through formal school was rare for women. A temple training and oral teaching helped to preserve and pass on astronomical knowledge across generations. This clay image for Anuna and in Haduna. Anana and Haduna, sorry. Now we arrive to the second period, which is Islamic Golden Age from 750 to 1258 CE. During this era, Baghdad became the world's leading center of astronomy, science, and engineering. At the heart of this rise was Bayt al-Hikma, House of Wisdom, a research hub like today top university, where the scholars translate work from Greek, Persian, and Indian astronomy. They create detailed Zayt astronomical tables to predict planetary motions. Khalifa al-Ma'mun built the Shamasiya Observatory in 828 CE, the most advanced of its time. Scientists invited and involved tools like Astrolab, Armilla's sphere, and quadrant. Baghdad Observatory became a beacon of learning, influenced astronomy from Spain to China. This image represents astronomical diagram from Al-Biruni in the 11th century. Sorry guys, I need to wake you up and ask this question to show you are with us, still with us. I have a small question. Who was the first to calculate the length of the solar year with impressive accuracy? Only 2-minute error. Johann Kepler, Al-Battani, Al-Khwarizmi. You can put your answer in the chat box if you want. We have one answer, C, Al-Khwarizmi. Okay, Rick said it's Al-Khwarizmi. Natalie said it's Al-Khwarizmi. No more? Okay, we have to wake up. Thank you. Okay, the right answer, sorry Rick, it's Al-Battani, wrong answer. The who discovered this, Al-Battani, as we will see now. The key advanced astronomy from Baghdad Golden Age, I take, for example, Al-Khwarizmi from 780 to 850 CE, mathematical foundation, develop they sent hand astronomical tables, introduce algorithm for planetary positions, improve trigonometry in astronomical calculation. Then we have Al-Farghani from 800 to 870 CE, planetary model and education, estimated Earth size, reversed Boltami model, and his work become core mental in the European astronomy. Then we have Al-Battani from 858 to 929 CE, celestial mechanic, calculate the solar year with very accurate value, measure Earth tilt also with very close to real value. First use science in astronomy instead of old Greek way. Finally, we have Ibn Shatur from 1304 to 1375, modeling and instrument. He created model similar to Copernicus. He was the first before the Copernicus who design this model, fixed lunar model error, and design celestial calendar tools. Islamic astronomer, now we go to the tools. Islamic astronomer did not just use ancient tool, they improved and reinvented them, turning simple device into powerful instrument that shape astronomy for centuries. I take, for example, Astrolab, a famous instrument enhanced by Muslim science to observe the sky, used to calculate star and planet position, tell time, and determine prior directions. Upgraded with a blade for different altitude, improving accuracy and portability. Armillary sphere, a 3D model built from metal ringing showing the path of a star and planet, helped visualize the celestial sphere and how heavenly body move. Used ring to mark the equator, the eclipse, and the sun path through the years. A quadrant cycle device used to measure the height of a star or a sun above the horizon, helped early astronomers track time and study motion in the sky. Different types were made, some with added trigonometry scale for better precision. Finally, we have celestial globe, spherical star map showing a constellation and major stars, used for education, timekeeping, and navigation. Many star names from this globe are still used in modern astronomy. Role of women in the Islamic age. Despite social restriction, some women quietly shaped astronomy in Baghdad through family, religions, and scholarly rules. Manuscript and science. Women work as scribe, copy star, chart, and texts. Some found book and keep private library. Al-Majdaliya made astrolabe used by Baghdad astronomy. Al-Muhammadi solve complex math used in astronomy. Education and learning. Elite women learned at home or through private tutoring. They had access to the astronomical books and family knowledge network. Culture and religious rule. Women in the royal and religious cycle supported astronomy. They joined moon sighting and revered knowledge despite being rarely named in records. Now we arrive to the third and dark one, colonial period. After Baghdad fall in 1285, science, astronomy on Iraq is declined, but astronomy didn't disappear. It survived through its use in religions. Now we will see how that. Madaris, it means schools, keep basic knowledge alive for prior time and lunar calendar. Iraq became disconnected from global science during the Ottoman and colonial era. Astronomy stay practical, not theoretical, focus on daily need and not for discover. Practical application, this is why we say that the religions keep the astronomy alive. Prior time, determine the 5 daily prior times based on the sun position. We need astronomy. Moon sighting, determine Islamic month beginning like Ramadan. So we need astronomy. Qibla direction, finding the direction of Mecca for prayer orientation. We need astronomy. calendar keeping, maintaining the lunar Hijri calendar for festival. So also we need astronomy. Rule of women, although women had no recorded formal rule in astronomy during this time, they likely contributed indirect way, like, for example, participated in moon sighting and calendar costume within household, passed down knowledge of lunar phase and time orally, especially among older women in religious communities. Their presence in this era was quite but significant, especially in preserving ritual astronomy. Modern era from 1900 to 150 to 2003. This period marked Iraqi return to astronomy after centuries of decline. University reintroduced astronomy, public planetarium opened, and large-scale national projects were launched, revealing Iraqi ancient legacy through modern science. We don't forget women also began to take part in the academic program and research, laying the groundwork for future contribution in astronomy and space science. In this presentation, I will focus on three large projects for astronomy. And also I want to wake you up with this simple question. Do you know where the twin of the Iraqi single dish radio telescope, similar in design and purpose, is located? We have three options: China, USA, Spain. This image represents the Iraqi single dish telescope, 30 meters. I think Eric said B. J. Good. We have one is wake up. Okay. Eric said B. B. Oh, USA, A, China. I think it's ABC. Okay, B. I think the right answer it's Spain. Eric is the good answer. This exactly the same, because I spent 2 weeks when I did my PhD in Granada, Spain. There is a catalog in Arabic language talk about the Iraqi telescope in this IRAM telescope. So we'll start with the first large project, the Iraqi National Observatory in 73. For me, at least, this project stands as a crown jewel for Iraqi astronomical effort, because we'll see why. It's located in the Mount Korek in the north of Iraq, with 2,130 elevation, more than 250 clear nights per year. And this site was selected for its exceptional atmospheric condition, low light pollution, and stable weather pattern, making it ideal for location for both optical and radio astronomy. Historical timeline for this project start in 73 in the last century. Project officially launched between 75 and 79. Construction phase with international partner. Between 80 to 90, work halt due to the war, site partially damaged. Between 91 to 2003, Gulf War destruction, operation ended. From 2003 to until today, there is nothing, it's still inactive. Technical equipment. This facility contains 30-meter radio telescope, millimeter wave receiver designed for galactic and extragalactic radio astronomy, 3.5 optical telescope, reflector with advanced spectroscopic capability, among the largest in the Middle East during that time. I think just until now there is nothing like that. 1.25 optical telescope, secondary tools for specialized research and educational purpose, supporting infrastructure, research laboratory, data processing facility, staff resident unit, and underground connection tunnel. The Iraqi National Observatory was one of the biggest science projects in the Arab world during the 70s. It connects Iraqi old history in astronomy with the new goal of space research. This is how it look like today. The telescope, as you can see, is damaged. There's no way to rebuild it. There is an mobile antenna and many stuff there, so it's almost finished, destroyed. The second large project for this presentation is the Al-Abid satellite launch system. Built in the late of 80s, Al-Abid was Iraqi most ambitious project to build its own rocket system for sending satellite into space. It showed how serious Iraq was about joining the space age. The height of this rocket is 25 meters, weight around 50 tons, contain 3 stages. The first stage, cluster of 5 modified Scud missiles, provide initial thrust. Second stage, design for altitude and velocity gain after first stage separation. Third stage, final orbital insertion stage for payload deployment. Even with limited tools and resources, Iraqi engineering work hard and show a great creativity in building a rocket system. This project prove that Iraqi scientists could do advanced work in space technology. Although the program didn't last long, I have to say that, it shown Iraqis a strong desire to be part of the space science and its ability to innovate, even in tough time. Launch history in December 5, 89, first and only test launch from Al-Anbar facility. After around 45 seconds, the rocket became unstable because its part separated too early. 19 to 91 program terminated following international sections. Al-Abid was one of the most advanced space rocket projects in the Middle East at the time, even though it was only tested once. As you can imagine, this is it was a secret project. There's no many image of this project, but when I search on the internet, I take this image from report from United Nations. It's you can find it online. It's free. And when I look on the YouTube, I found this video footage broadcast by Iraqi National Television in 89 following the launch tests. Very short but interesting. Can see it. The third project was Altar Experiment Satellite, Iraqi first satellite project between 88 and 90. It's octagonal shape with 74 centimeter diameter, 47 centimeter high, and 75 kilogram mass. Power system, 7 solar panel with battery backup provide continuous operation. Communication VHF, UHF, transponder for transmission and experimental range. Mission duration designed for 2 years operational life in low Earth orbit. Instrument, basic Earth imaging camera, and atmospheric sensors. These satellites represent a significant technology achievement for its time, with a specification comparable to early microsatellite developed by established space program. Development timeline for this project start in 88, initial design phase by Iraqi Scientific Research Council scientists. In 89, completion of 2 flight-ready prototype, initially launched plan by Iridium 4, but later in 90 shift to launch with Al-Abid rocket program. Finally, in 90 project shut down following international section and satellite never launched. Scientific purpose and legacy for this project, designed to establish Iraqi capability in satellite communication and basic Earth observation, would have provide valuable atmospheric data and telecommunication experience, trained a generation of Iraqi engineering in space system design, whose expertise continue to contribute to current project. Even this satellite is never launched. Altair project represent a milestone in Middle East space development effort. The technical documentation and engineering knowledge laid a groundwork for later regional satellite program, including the successful TigerSat micro CubeSat launched in 2014. This is two image, external view and inner view of this experimental satellite. Also, we have, sorry, I have last question. You need to wake up. Who was the first Arab woman to earn PhD in astronomy? You have three options: Dr. Shadia Habbal, Dr. May Arif Kaftan, or Dr. Maryam Shadid. Which one is the first one? Shadia Habbi, Hassan Saibi. Okay. We have two person wake up, 3 person wake up. Okay. Hey.
Guarda che ciò che lo che
Okay.
Yo no sé si iban a dar comida. Dicen que como no hay presupuesto, no creo que no hay comida. Pues.
Sorry, I can continue. Women contribution to astronomy on Iraq became visible in this modern era, especially through a pioneer figure like Dr.
Excuse me, please, excuse me, please shut your microphone.
Lydia,
Please shut your microphone.
Sylvie, you can make the mood for Lydia.
I can do that, but I don't know how to do that.
Yeah,
I'm
you
sorry.
go to the participants. You have a little mic, a picture of a little mic. You can click on and change to mute because you are the host.
Yes, I know, but I don't know. You said to me where I have to go, but I don't understand where I have to go. I'm sorry.
Okay.
What did you say? How to find the...
You go to the participants here for me it's in down of my screen. Participants, or I don't know the name on French. Personne.
Go to the participant.
Participant, eh?
Oui. And choose the person who has mic open and close it.
Participants. So then...
So I
Yes,
open in
I have found that.
Okay.
I have
Perfect.
found that. Thank you very much. I just had to go to participants. Yes.
Yeah.
So I think it's
Perfectly.
Okay. Sorry for that.
Please.
So can I continue now?
Yeah.
Okay. Let's start again. We are in the modern period, and we arrive in the role of women. Women contribution to astronomy in Iraq became visible in the modern era, especially through the pioneer figures like Dr. May, one of the first Iraqi women in astrophysics. She has a notable achievement. She born in 28 in the last century in Baghdad to a distinguished family. Her father was a government official. Early 50, complete study in physics at the University of Manchester, UK. In the 58, earned a PhD in radio astronomy from Harvard University, under supervisor to Cecilia Bain-Gabushkine and Bart Bock. In the 60, worked at the National Radio Astronomy in the United States. In the 70, she returned to Iraq to establish astronomy program at the University of Baghdad. From 81 to 2020, returned to the United States due to the political pressure, continued international collaboration until her passing in Virginia. Scientific journey for Dr. May. She helped to design the Iraqi National Observatory at Mount Qorik using her international experience. Published research in radio signal from galaxy. So she helped to build a new field in radio astronomy. Created the first astronomy program at the University of Baghdad, inspiring future Iraqi astronomers, women and men also. built strong scientific connect with international institute like Max Planck and Harvard University. Legacy for Dr. May. She was the first Arab woman to get PhD in astronomy. She opened the door for many women in the Middle East to follow a career in science. A global acknowledgement for Dr. May. Following her passing in 2020, Dr. May Arif received an official tribute from an International Astronomical Union, a rare register typically reserved only for IAU president or general secretaries. This exceptional recognition reflects the profound legacy she left behind in Iraq and Arab world. As you can see, the upper image is the official email from Prof. Teresa Log approved their exceptional tribute for Dr. May. The lower image, it's IAU tribute for Dr. May, published in the official website of and shared wide international. Now we arrive to the period 5, present-day astronomy in Iraq from 2003 to present day. After decade of interpretation, astronomy in Iraq entered a new era of recovery and ambition. From rebuilding university program to launching satellite and rejoin the global astronomical community, this period reflects Iraqi determination to reconnect with cosmos. From 2003 to 2008, astronomy education resumed at major university. 2014 launched TigerSat, Iraqi first satellite built by students in collaboration with Italy. 2014-21, Iraqi rejoined to the International Astronomical Union. 23 opened the Space Technology Engineering Department. 2022-25, astronomy grew fast through citizen science, public event, and the youth lead activity across Iraq. Academic revival in astronomy. The Department of Astronomy and Space at the University of Baghdad offer full undergraduate and postgraduate program. Astronomy also teach in the physics department in other Iraqi university. In 2023, Iraq opened a new space technology engineering department at the Engineering Technical College in Baghdad. It's a brand new program, so it hasn't graduated any student yet, but it's an important step for space education. Research in Iraq, including theory, observation, and computer modeling, often done with help from international collaboration. Faculty also work in lunar calendar, eclipse protection, and help raise public awareness of space event. These figures show growth of astronomy education in Iraq from 2005 to 2023. You can see it's good regarding what's happening in Iraq. And this is image of the astronomy department on University of Baghdad. Global integration and local engagement. Since 2018, Iraq has reconnected with the global astronomy community. It's appointed its first national outreach coordinator, NOC and NIC, in 2020. In 21, Iraq became a full national member in the International Astronomical Union, category OB. Inside Iraq, astronomy club and local group have grown. They host star parties, public talks, and sky watching event in the city, different city in Iraq like Baghdad, Basra, Erbil, and Mosul. Iraqi amateur astronomers have won an international award for astrophotography, and Iraq joined global events like NASA Citizen Science. This some image for some astronomical activity in some of them in historical places in south of Iraq here, like in Ur. This is in Babylonia. This is in public park, and this is an image for one of Iraqi amateur win a telescope from IAU. This is in the university, and this is in public park. Bringing space to the public, the infographic astronomy project. This project founded by me. The goal of this project make astronomy accessible for all people, regardless of level of education and sex and age. And it's published for a weekly series in the social media. it's continue for series, which is general infographic. It's published on Friday. Explain real astronomical event in a simple visual style. Astronomical fact published on Monday. Short surprise fact based on real science. The third one is What If, published in Thursday. Explore imaginary or rare space scenario with science-based answer. Finally, Little Astronaut, Saturday, because it's day off. A fun and educational series for kids with space fact and activity. These figures show the growth of digital engagement with Iraqi astronomical contact between 2018 and 2025. As you can see, it's almost good regard to what happened in Iraq. This is an example of this infographic project. And I have to say that some infographic, this poster are shared every Monday by the IAU Office for Astronomy Outreach and their Facebook page to reach the wider audience. We are also work with NIAL to publish selected content with English translated on OAI website. From infographic to book, expanding astronomy access on Iraq to Iraq. Part of this project, part of the astronomical infographic project was transferred into a full color printed book with the title Astronomical Infographic Encyclopedia to reach new audience offline. Thanks to partial funding from the IAU, the book was professionally printed and distributed free of charge to public school, science club, and amateur astronomy group across Iraq. It's 200 page with a size paper A4 with hardcover and color. It's expensive, but it's okay. Role of women for this day. More women are now studying astronomy and physics in Iraq University. They are active in research, science communication, and public education. Many have joined amateur astronomy club, especially in photography and sky watching. Some women lead events like star parties, lectures, and school competitions. I will give one example, a leading example, which is Dr. Zainab Qasim, head of the astronomy division at Ministry of Youth and Sport. She helped to establish astronomy team for amateur in every Iraqi city and continue to support and coordinate astronomy activity all around on the Iraq. This change show that Iraqis became more supportive of women in science and space. This figure, I don't know if you can see it. It shows the growth of female participation from 70 to 2003, and as you can see, its growth also. This picture of some astronomical activity led by women. This is in a school. This is in city public park. This is in city public park, schools, mall. I think this is in the university. This is an portable platinum in schools, and this is in the mall. So you can see women are really good participate in astronomy. Conclusions. Iraq's journey in astronomy span over than 4,000 years, from clay tablet to the space technology. Each era brought unique idea, tools, and challenge, but the sky always stayed part of Iraqi identity. Women contribution at every stage, as we saw, from tablet calendar to radio telescope. While I didn't focus on the challenge of the working in Iraq, like limited funding, safety concern, and travel restriction, the truth is, doing astronomy here can feel like a nightmare. But despite all that, we keep moving forward, because on Iraq, even when the sky is full of cloud, we still look up and dream beyond them. Iraq astronomical story isn't over, it's just entering a new chapter. And thank you for your listening. I finished, Sylvie.
Yes, we have some question in the chat.
Here we are. Okay, so much thanks, Ali. That was very interesting talk, and we can see that astronomy in Iraq is in an uprising way, and that you are also, how to say, you have a very important role in that. I mean, you didn't say that for everything, but we can see that you have an important role.
Thank you.
So
Thanks
yes,
a lot.
there are some questions. I mean, there are some several people saying that this was a very interesting talk, and someone, Tiffany, is asking about further books or something to read, and so maybe you can say tell if there is some books or some things
In fact, there is many
people could
books
read.
in English about because I don't know which period she or this person want to speak to read about it.
That's Tiffany
She
Patterson. Tiffany
what you want
Patterson.
what you want to
Tiffany,
know.
Tiffany, could you open your microphone and ask your question? No.
I think she write in the chat about women on Iraq and women in
No,
astronomy.
she says, are there any recommendation on further readings on this topic? But of course, this topic is quite large.
Exactly. Which which topic she mean?
So
In the
she
end
has
of
to
the
say
chat,
she has to say something or something else in the chat. I don't see. Ah,
She
women in
women on
astronomy. Oh,
Iraq.
she said women in astronomy, and she said I can't speak because I'm at work. So
Okay.
about women in astronomy in Iraq. But
Uh,
maybe you
the,
don't answer now, or if you can answer, but maybe just asking her about her mail address and tell her later on.
I put my mail. She can connect with me if she need more information
Okay.
about
Okay. So
astronomy, women astronomy in Iraq. But there is no book speak about that. There is no specific book speak about the role of women in astronomy in Iraq, or as my knowledge. Maybe there is, but I don't know.
okay. And uh, so several people thank you and say excellent presentation
Thank
and
you. It was
great
glad to
talks
be
and
here.
informative and so on. So much thanks. There is a question by Hassan Farid. I was a postgraduate student. It's good to see you. My question is, does Iraq has real in capital letters, real plans to join the space race anytime soon? And in fact, I had a connected question about the collaborations. Are there any planned collaboration? You spoke about a collaboration with Italy at what some time in your talk. Collaborations between Iraq and other countries about projects. Uh, Maybe
Yes.
it's not exactly the same question, but you can answer both.
Sorry. What your question exactly
Oh,
about?
my question is about collaborations of space. Is there a space agency in Iraq?
No, there is no space agency
No,
on
but
Iraq.
the people who I don't know who work about space.
Situation on Iraq is very complicated these days. But as I said in my conclusion, I didn't speak about the difficult.
Yeah.
I want to stay positive. But
Okay.
normally there is an center called Al-Battani Research Center for Space Science. They have very good science and they do very good things. But regard what going on in Iraq, this they cannot really do good work because there is no funding, no money, and I'm sorry to say that, but this is the fact.
I think it has to be said. We have to know, and so that's probably an answer to the question by Hassan Farid about are there real plans to join the space race. There is the question of fundings is important.
Iraq has a very good experience. As I show in my presentation, we have a 30-meter radio telescope. We have a space launch vehicle. We have very good science. We have women work in this field, but the situation is the problem with the situation is not really stable. Always not stable. There's always a problem there.
There's another question. Could you talk a bit more about your relationship with, maybe it's related, your relationship with the Iraqi government and how they are supporting the growth of astronomy? I guess that's you have answered already, but
No,
difficult.
they don't support any kind of science, not astronomy.
Okay,
There is no funding for research.
so how, at the present time, how can you manage to do anything? I mean, it's just people, voluntary people.
Okay, if you remember this project, this is infographic project for some fly astronomy for everyone. It's cost $6,000. I take partial fund from IAU 2,000, and I pay from my money, private money, 4,000 to print this book. As you see, so people work, but they from their money. It's not from the government. And also this very, very difficult because I don't feel it's Kelly here, Kelly with us or no. And I work with Lena and Kelly to get this funding. It's late for 6 months to transfer money from IAU to Iraq. There is a very difficult to transfer money to Iraq. It's not enter Iraq. Even it's I give him the account of the printing house. It's not a private account, but the money is not enter Iraq. I wait 6 months, and after 6 months we didn't manage to get it. They transfer money to the France private account and take money from there.
Oh, wow.
So yeah, the situation in Iraq very difficult and very restricted for get a visa to travel. The situation really not a good environment for the scientific work. But we, as I said, we are still working, still alive. People like alive and like work, and we're still here.
You know what? We have to thank you very much because it's very important for all of us to know that.
Thank
And
you. As I said, I'm very grateful to give me an opportunity to speak about astronomy in Iraq. You can see I don't want to speak about the negative things. You see too much negative things on media, so you don't need to speak about that here also.
in
Here,
other countries also, but
exactly. Here we speak about positive thing. I hear because we do science, but in the at we as much as we can, not because astronomy need money, need not a personal support. This is a government. As I think NASA each year has more than 20 billion per year. So there is no comparison between what Iraq is zero for research. There is nothing.
well, do you think about anything at international community in this commission
we are
Signal,
we
for
are
instance,
welcome
can
with
do to help you?
we are welcome with all kind of cooperation.
Very interesting. Someone says it's Genevieve Marshall. Thank you very much for your answer. Yes, the bank transfers are very difficult indeed, which alongside issues like visa and no research funding is a huge challenge. The achievements of scientists in Iraq are really tremendous in the face of the adversity you face, positive and inspiring. Okay, so I think that's the most important, that you are really going up to the future and be positive. Are there other questions?
I don't have a question probably, but I want to thank you very much to share this information. Many of these I didn't know before, and I'm sorry about it, but like you said, usually the news in the newspaper is only about other things uh, over Iraq. It's not about science and not about these things. So I'm very happy to know about it and to know uh, you have some people working in science, in real science, and share information, share science in Iraq. It's amazing for me. I totally understand the problem of budgets for this because I'm from Brazil, and Brazil sometimes we have problems with budget for science. I think all the countries is like this. So we have more budget for war and less budget for university. So
Unfortunately, yes.
yeah, unfortunately, totally. But
Thank
I
you very
am
much for your kind word. This is mean too much for me. I am happy
oh
to make you know this information for you.
no, I'm very happy to be here. It's amazing. Thank you very very much.
Thank you very much also.
I think there are some problems everywhere at the present time, and we are not going into that. It's political questions. It's important political questions, but maybe we are not going to get into that now. But we have another message from Geneviève Marshall from IAU. She said that with Ramdin Gopal, who is at the OAD in IAU, they would like to speak to you if you have time. So
Yes, for sure.
you
Yes.
can she's you have the chat, so you can see the mail, and so they are interested to discuss with you. So this is very, very nice,
Yes,
very
that
positive.
will be happy for me
So you
also.
have to do that.
Okay.
Yes,
Yes, sure.
and Ram, it's a very nice guy to share these informations
Oh
from
yeah,
OAD.
oh yeah,
Yeah,
I
it's
know him
amazing.
too.
Yeah, yeah.
Okay. So maybe we will stop here and just thank you very much, Ali. And it was a very nice, very interesting presentation. And I think there will be some discussion afterwards. I think it's important that you could give this talk. So thank you very much, and thank you to all the people who were listening to your talk. And
Thank you.
this is recorded. So in a while, in a short while, it depends on Vinicius. In a short while, it will be accessible on the web. The people who have listened to it may be able to go back, and the people who could not be here today will be able to listen to it. So thank you very much, and bye-bye, and see you soon.
Thank you very much. See you. Bye.
Bye-bye.
Bye.
Thank you, everyone.
Bye,
Bye.
everyone.